In this task, you'll explore two ways to measure proximity. You'll learn how to apply both the buffer tool and the heat map tool to measure proximity to fast food restaurants in Baltimore City. Here I have QGIS Desktop open with the QGIS map document from Lab 4 Task 1. First, I'll buffer the fast food restaurants. Buffer is an operation that creates a new polygon layer that's a specified buffer distance from another layer. To begin, I'll click the Vector menu, go down to Geoprocessing Tools, and find Fixed Distance Buffer. The input layer will be Baltimore fast food. I'll set the distance to 1320. This is the number of feet in a quarter mile. I'll set segments to 20. QGIS can't create true curves, but the higher this number, the smoother the output will be. Next, I'll check Dissolve Result. Checking this option will merge the buffer polygons for each point together if they overlap. Finally, I'll check the ellipsis next to Buffer and choose Save to File. I'll navigate to my Lab 4 My Data folder, and I'll name the output Fast Food Buffer. With that set, I'll click Save and then Run to run the operation. The new layer appears on the map and in the Layers panel. It's named after the operation I just ran, Buffer. If I hold my cursor over it, though, I see that it is the fast food buffer shapefile that I saved. I'll drag the layer beneath the Baltimore fast food layer. This new dataset shows the area of Baltimore that's within 1/4 mile of a fast food restaurant. With this data, I could calculate the percentage of Baltimore that's within 1/4 mile of a fast food restaurant. You'll learn how to calculate acreages in Task 4. That created some good information. Now you'll learn another method of calculating proximity. I'll create a heat map of the fast food restaurants in Baltimore City. A heat map is really more of a measure of density computed from point data. A raster surface will be interpolated from the point data. To do this, I'll be using a QGIS plugin named Heatmap. It's a core QGIS plugin, so it's already installed. You just need to enable it, which I've already done. To open the tool, I'll go to the raster menu, scroll down to Heatmap, and open the tool. I'll set the input point layer to Baltimore fast food. For the output raster, I'll navigate to my Lab 4 data folder and name it fastfoodheatmap.img. I'll set the output format to ERDAS Imagine images. I'll set the radius to 5,280, the number of feet in a mile. Then I'll click the Advanced checkbox to access some advanced settings. Here I'll enter a cell size X and cell size Y values of 100. Finally, I'll choose a kernel shape of Epinekhanov. The kernel shape controls how the influence of a given point decays as distance from it increases. Epinekhanov results in smoother hotspots. With those parameters set, I'll click OK. A raster image appears styled on a black to white color ramp. Next, I'll style this raster layer. To do this, I'll open Layer Properties for this layer, and I want to be on the Style tab. First, I'll change the render type to single band pseudo color. Then under Color Ramp, I'll choose yellow, orange, red. I'll expand Load Min-Max Values, and under Accuracy, choose Actual, Slower, and Load. To set the color, I'll click OK. This layer extends beyond the boundary of Baltimore City. So next, I'll clip the heat map layer. To do this, I'll click on the raster menu, choose Extraction, and select the clipper. The clipper window opens, and I'll set the input file to Fast Food Heat Map. For the output file, I'll click the Select button, browse to my lab data, switch to ERDAS Imagine, and I'll name it Fast Food Heat Map _BC for Baltimore City. Next, I'll click on the Mask Layer button and choose the Baltimore City boundary as the mask layer. With those parameters set, I'll click OK. The clipped heat map layer is now on my map, but I need to style it. To do this, I'll use a trick. I'll right-click on the original heat map layer, choose Styles from the context menu, and select Copy Style. I'll then right-click on the clipped heat map layer, choose Styles, and paste style. With that done, I'll remove the original heat map layer. In the next task, you'll learn how to select features.